In May 2025, astronomers reviewing data from the James Webb Space Telescope spotted a faint red smudge of light. It turns out that smudge is the most distant object ever seen by human eyes. Looking at this timeline of the universe, starting with the Big Bang on the far left, we can place this newly discovered galaxy, fittingly named MoM Z14, right here. It existed a mere 280 million years after the cosmos was born. To put that sliver of time into perspective, we can add the evolutionary history of sharks to the board. Sharks have actually been swimming in Earth's oceans for a longer period of time than the entire universe had existed when MoM Z14 was shining. Astrophysicists at Yale and MIT are calling this observation a cosmic miracle. According to our established models of early galaxy formation, a structure this bright and complex simply shouldn't exist that early in the timeline. To grasp why this tiny red dot is causing such a stir among cosmologists, we first have to look at the strict set of physical rules it appears to be breaking. The foundation of our modern cosmic rulebook was written in 1915 by Albert Einstein, when he published his theory of general relativity. Einstein showed us that gravity isn't a magnetic-like pull between objects. Rather, massive bodies actually bend and warp the physical fabric of space-time itself. And that canvas is not a static backdrop. It is actively stretching outward in all directions. As space expands, any light traveling through it gets stretched along with it. The wavelengths of that light become elongated, shifting toward the red end of the electromagnetic spectrum. Astronomers call this redshift. The James Webb Space Telescope is specifically optimized to detect these deeply stretched, highly redshifted wavelengths to locate the oldest phenomena in existence. Because light travels at a finite speed, peering across these vast distances means we are looking backward in time. Catching highly redshifted light allows telescopes to capture the universe exactly as it looked billions of years ago. Rewind the clock all the way back, and the universe began as an intensely hot, incredibly dense singularity. As that early universe rapidly expanded and cooled, subatomic particles collided and fused together. This process, known as nucleosynthesis, produced only the two simplest elements in existence, hydrogen and helium. Because of this, standard cosmological models assume that the very first generation of stars to ignite in the dark universe would be composed entirely of those two simple elements and nothing else. But this emission line graph tells a different story. When researchers analyzed the light from MoM Z14, they found these distinct spikes. The galaxy contains the unmistakable chemical signatures of carbon and nitrogen. Astronomers refer to these heavier elements as metals, and there is only one known way to create them. They are forged under the extreme pressure found inside the cores of dying stars. Those metals are then scattered across the cosmos only when those older stars eventually explode in cataclysmic supernovae. Finding carbon and nitrogen means it cannot belong to the first generation of stars. An entirely older, hidden generation must have already formed, lived, and exploded before the universe was even 280 million years old. MoM Z14 serves as a signpost pointing toward a completely unknown, highly active epoch of the early universe. In fact, astronomers are currently finding roughly 100 times more bright galaxies in the early universe than pre-Webb observations ever predicted. The cosmos was building massive structures much faster than our models accounted for. Armed with this $10 billion observatory, astrophysicists are now having to rewrite the timeline for the universe's so-called dark ages. As we can see on this redshift scale, the search is now pushing past MoM Z14's mark of 14.4. Astronomers are aiming for redshifts of 15 or 16, venturing into this unexplored dark zone to find the true metal-free first wave of primordial galaxies. This doesn't mean the overarching Big Bang model is broken. The foundation remains solid. What is shifting is our understanding of exactly when the lights first turned on. The discovery of MoM Z14 confirms that the story of how the dark universe first lit up is more complex and began much earlier than our models ever predicted.